Everybody, I'm going to talk a little bit about bonds and orbitals in this video. So it really helps us to kind of think about what are the bonds that are making up a molecule, what orbitals are making up those bonds. So this is going to be a little bit of a rundown on just kind of the bonding and the orbitals that make up those bonds. And then in another video, we're going to talk about how to identify which orbital is actually responsible for making different bonds and stuff like that. So we first want to remember that in any type of kind of hybridized atom situation, if we've got an sp3 atom, we're going to have 4 sp3 orbitals. So remember 1 s and then 3 of the p's, total of 4. For sp2, we're going to have 3 sp2 orbitals, 1, 2, 3, and then our leftover p orbital here. For an sp atom, we've got 2 sp orbitals and 2 p orbitals. If you're not feeling comfortable with that, make sure you go back and watch that video where we talk about hybridization. In any case, any of these hybridizations, we're always going to have 4 orbitals present. So whenever you're kind of thinking about what orbitals are present on any given atom based on their hybridization, that number should be adding up to 4. And if it doesn't, you need to double check your work. Okay, so orbitals present on each atom, 4. All right, so for sigma bonds are always going to be formed from hybridized orbitals, okay? So we're looking at hybridized orbitals here. So if we're looking at a sigma bond, if we kind of think about our hybridized orbital and what it's made out of, they start off with some number of p's. Okay, so some quantity of p orbitals are going to get averaged in together with an s orbital. Okay, that's the s and the p orbital coming together, and we're going to average those out. We hybridize those, and then we get out some kind of hybridized orbital. Oops. So hybridized orbitals are usually drawn with kind of one larger end and one smaller end, but kind of look like that p orbital shape. But it's like if you just took this and then glommed it into that top piece. So that top piece is now bigger. So that's kind of where the shape comes from, and that's why it's a little bit confusing to tell what's hybridized, what's a p orbital. You're kind of looking for an unevenness in the p orbital shape for that hybridized orbitals. So this could be sp3, it could be sp2, or it could be sp, okay? Not all of these together, it's going to be one of these, okay? So then we have one atom with a hybridized orbital and another atom with a hybridized orbital, and they're going to come together to form a bond. So the way that we normally see this is we're going to see some atoms. We're just going to use a little carbon atom here, another carbon atom here. So this carbon atom has its hybridized orbital. Let's show you the other side. Keep in mind, the shading doesn't really matter which side you're doing it on, as long as you still have that node in the middle, so the place where the two colors don't match. And if you want to be making a bond, you need to have the two colors matching where you want the bond. So essentially what we have right here is we've got 2 hybrid orbitals. And those are going to come together. We can kind of animate this. Oops. If I can, let's see if I can. Oh, goodness. Okay, I will animate it down here and then put it over there. Good grief. Technology's getting the best of me. Okay, so we can essentially animate what's happening here as these two overlap. Then we are forming a bond in between. Okay, so this is now a new sigma bond. Okay, and we're looking at that electron density sitting between the two atoms. So the other thing that we can have is we can have a carbon, for instance, with its hybridized orbital, and an H with its s orbital. So hydrogen atoms can't hybridize, right? They only have the one s orbital, so they're a lot more limited. So when we're looking at something like this is one hybrid orbital and then one s orbital. And when those two things combine, then we get a picture that looks kind of like this. Okay, where we still have that electron density in between the two atoms, but we just have that s kind of overlapping with that hybridized orbital. And that's also going to form a sigma bond for us. Okay, so if we look at what that looks like in a simple molecule, and this is a picture from your book, so feel free to look at this picture whenever you want. It's in your book, it's nicely explained. So this is ethane. Okay, so we've got two carbons. They each have 3 hydrogens on them, and the 2 carbons are bonded together. So if you look here, this in the middle, that's the overlap of this, right? That's showing your electron density holding these 2 carbon atoms together. And then we have, similar to this picture, oops, which I didn't shade. So similar to this picture down here, we have that for each of the carbon and hydrogen bonds, okay? So each of these is holding 2 electrons in it, so 2 electrons to form that sigma bond. Okay, so we're essentially thinking about, you know, the carbon bringing in one of those electrons, the hydrogen bringing in one of those electrons, and together they're going to form a bond there. Okay, so then if we think about pi bonds, so pi bonds are a little bit different. Pi bonds are always going to be formed from actually atomic orbitals, and they're going to be formed from that p orbital that's left over. Okay, so if we look at a regular p orbital here, I'm going to try to draw those as evenly as possible. So a p orbital, we've got the node in the middle, meaning that we don't have any electron density right at the atom, which is in the center. We've got a possibility for electrons to be sitting in either of those 2 bubbles at the top, okay, of that kind of infinity sign. So if we think about these as being carbon atoms, we'll just put a little C in there. So if we've got those 2 coming together, so in this case, our constructive overlap, we want it to be unshaded to unshaded, shaded to shaded. So we're looking at this overlap, that overlap, and that's going to be our pi bond. Oop, as I write sigma bond. Okay, so that is our pi bond. So the pi bond is not the only bond that is present though, because actually holding these 2 carbon atoms together as well is a sigma bond. Okay, so our sigma bond here is that electron density in the middle, which is what we have shown right here. Again, that sigma bond is made up of hybridized orbitals. And then our pi bond is made up of these p orbitals that are perpendicular to that, okay? So they're going to have more electron density kind of in the top and in the bottom, above and below those atoms. Okay, so we've got electron density. Okay, so if we look at this, which is ethene, this is all of the orbitals that are present in this molecule. So we've got the sigma bond here with the electron density between. We've got the pi bond here with electron density above and below. And then we've got more sigma bonds for the C and the H, okay? So again, those are going to be made up of our hybridized orbitals. So in this picture, the hybridized orbitals are in gray. And then our p orbitals are red and blue. Okay, so when we're looking at that, we've got one orbital there is our sigma bond, one is our sigma bond, one is our pi bond. So when you're looking at this picture, you can kind of think about, you know, like one of these lines. So maybe that's your sigma bond, and then that's your pi bond, giving you a double bond and showing that you've got kind of multiple things holding those atoms together. All right, so triple bonds are a fun one. So triple bonds actually have 2 pi bonds. Okay, so if we're looking at acetylene, which is this guy. Okay, so now we've got 3 lines holding those carbons together. So one is going to be a sigma bond. And then we're going to have 1 pi bond, 2 pi bonds. So total of 3 bonds holding those carbons together. So you can't have electron density sitting in the same places, okay? So the way that this happens is your sigma bond, as usual, is right in the middle of those 2 carbon atoms, right? So we've got our sigma bond right here. And then much like in this version up here where we had the 2 p orbitals that were perpendicular to that sigma bond, we've got the same situation right here, kind of up and down. But now we have another set of, again, perpendicular p orbitals that's happening right here, okay? So in each case, these are all perpendicular to each other, okay? Because we're basically covering 3 dimensions of orbitals here, where we've got kind of this one, that one. So we're looking at three different bonding situations where we have the pi bonds are perpendicular to each other and the sigma bond. Okay, so that's something important to keep in mind as we continue forward with this. So if we're looking at what orbitals we have here, so this is an sp orbital because this carbon atom is sp hybridized. This is 2 sp orbitals. And then we've got a p orbital here and a p orbital here, and then the same on the other side, okay? If I'm looking at this one, we've got our sp2 orbital is making up this sigma bond because this carbon and this carbon are both sp2. And then we've got our p orbitals, okay? And same on the other side. So the p orbitals are making pi bonds, the hybridized orbitals are making the sigma bonds. So I'm just gonna write that as our summary here. Pi bonds are made from p orbitals. Sigma bonds are made from hybridized orbitals. Okay, that is what you need to get out of this video. Alrighty, so as always, let me know if you have any other questions, and we will be practicing all this stuff quite a bit. See you later.